Okay, so the key phrase to look for here is the uh, effective interest rate. Now, there's a thing on your calculator that if you go into the thing called interest conversion, when you're in financial, go to calc and then see it's got a thing called interest conversion. And what we're looking at here is you've got this 3.73 times and you've got weekly, monthly, quarterly. Well, you should know the more often you compound, the better. So really, A is going to beat B and C. And so for the same reason, D is going to beat E because we've got monthly versus quarterly for the same interest rate. So really, we can already eliminate, just from our knowledge of compound interest, B, C, and E. So we now know it must be between A and D. So if I just check A, already that's going to give me the right answer. So I put in 52 because that's 52 weeks in a year, and we put in the APR of 3.7. No idea what APR is. It's the interest rate per something, I don't know, but it's the 3.7, and then you just click the F button. I like to call it the F trick, and I get 3.76, which is less than 3.8. And obviously the compounding should mean that your effective interest rate is going up. So it's not above 3.8, so it's already told you the answer is D. But just to show you that if you do 12 for monthly and 3.8 for the APR, you get an effective interest rate of more than 3.8, strange as it may seem. And the answer is, of course, D. Okay, so if we look at this, Mia has invested some money in a perpetuity, so that's a key point, perpetuity, and gets monthly. He receives a monthly payment of 525. You got an annual interest rate of 4.2 paid monthly. How much money did Mia invest in the perpetuity? Now, what you can think about is like, okay, look, you can put in, say, like 1 year if you like. Perpetuities, it doesn't matter the end. There's our interest rate of 4.2. We said it's compounded monthly, but we can also see that the payments are 525, positive because the bank is giving you money, and they're every 12 months. But that leaves us with a bit of a problem because we've got a blank here and a blank here, and we only want one blank, so we can press one of the buttons, PV or FV. And this is the problem with perpetuities, is that if you have to calculate the PV or the FV, it could be quite hard. But no, wait, they've given us some values. So we can do the old suck it and see which value is going to work. So my strategy here, and I have a strategy, believe it or not, is I'm going to start with this value, and if it comes out too low, I'm going to go higher, and if it comes out too high, I'm going to go lower to A and B. So what I did was I put those numbers in, and I put in minus 52,500 and positive 52,500. It's important to get those negatives and positives right. So negative is you gave money to the bank, and at the perpetuity at the end of the time, you get back the same amount of money. So I put in the 52,500, and you can see I then pressed the PMT button to see if it did equal 525, right? And it's too low. So it's too low. That means I can say it's not A, not B, and not C. Let's try the next one. So I did exactly the same thing, and this time I put in minus 120,500 and checked all the numbers, and I found that that was too low. Now that just leaves E, but sometimes you're in a bit of a panic mode in an exam, so let's check what E was. And E does work out. If you put those values in, you get the right number. You do in fact get a payment of 525. So the correct answer was E. And you can do a lot of this suck it and see sort of strategy with multiple choice questions. And it is a pain with these perpetuities because you kind of freak out with the solver. I know I do. Okay, so here's another suck it and see kind of problem, to be honest. We've got interest of 3.8 per annum compounded monthly. Cho has started with 85,000. They've added monthly payments of 1,500, and they want to know when it first exceeds 95,000. So I put those values into my financial solver. And this one's easy because you just got to press the F key. And what I did is I started with the n equals 7. Again, so if you start in the middle, you can work out whether it's too much or too low and sort of eliminate things quickly with the suck it and see strategy. So I put in 7 and I got this number out, and I found my final value was 97,502. So that is actually more than 95,000. So I can quickly then rule out 9 months and 8 months. Now, I can't rule out 7 months yet until I try 6 months. It looks like it's quite a fair bit past 95,000, 97,502. But we need to double check that. I'll just quickly remind you also about those numbers. So we did 7 for 7 months, 3.8 for the interest rate, minus 85,000 because you're putting it into the bank, and minus 1,500 because you're giving money to the bank. You're making payments, you're not receiving payments, and the payments are monthly and the compounding is monthly, just to remind you where all that comes from. Let me just delete all of that, and let's have a look at 6 months. 6 months, it does work out. Like you're still, you put 6 in, you're just changing one number and then pressing FV, and so we can rule out 7 months. And it looks like it's going to be 6 months because it's got quite a bit closer. And it looks like 5 months is going to be under, but we might just like quickly tap the calculator for 5 and see it is under. So it's not 5 months, it is 6 months. The answer is B. But again, just to suck it and see. I mean, it doesn't take much once you put the values in to just keep playing around with the monthly things until you get the right value. You could have started lowest and gone highest, but I think to start in the middle and sort of play up and down from there is probably quicker if you don't know which way it's going to go. All right, let's highlight our key numbers. And again, we're going to see this financial solver. It just has that smell of it. So 29,000 to buy a car. Interest rate of 12.5% per annum. Seriously, in the real world, most car manufacturers will give you a very, very good dealership interest rate, way, way below that. So don't go to a bank. Just a little life lesson there. Compounding monthly. For the first year, and then we've got a second year thing. So we've got a first year, second thing. That means we're going to do that sort of double feed thing. And there is always one question where you have to sort of put in 2 values into this thing. So you have to iterate on your financial solver. First year, 425. Second year, 500. How much interest? All right, let's put our first year in. So our first year is going to be 12 months. There's our 12.5% interest. We get 29,000 because we borrowed it from the bank and gave it to the car dealer. And then we made payments, so it's minus 425. Payments per year and compoundings per year of 12. And so we press the FV button and we got this number. All right. Now what we got to do for the next second 12 months is take that number and put it into here. And that's exactly what I've done here. You can round it off. It really doesn't matter all those other things. And so nothing else has changed except this. Remember, this is going to be made positive. And then we press the FV and we've got this number, 24,714.68, blah, 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 blah. And so they said it's going to be closest to a number. All right. So what we're looking at here is basically you started with $29,000, right? And you made some payments, which should have taken you down to here. But unfortunately, in life, you have to pay interest. So the interest is taking you back up to a value. And we know that value is 24,714, right? So we know what this down is here because that is how much you paid, and you paid 425 12 times and 500 12 times. So if you first take your 29,000, go down to this point, and then you see you get 17,900. So this should be 17,900. So whatever this distance here is, that's your amount of interest, yes, because the interest was charged against you and took the value of the loan back up again. And that's why we get the value over here of, so first of all, 29,000 minus the first year minus the second year of payments took us down to 17,900. So, and then that was our final value, which is going to be take away this number, and you get 6814.68, which is pretty close to 6,800. So there's your answer. But please get the hang of these double ones where what we did was we took that value from the FV and made it into a PV. Very common thing. There's always going to be a one like this. So please practice.